Welcome back, class. Today we are going to factor a polynomial expression that has a GCF. Let's get started. In this example, we have x to the third plus 2x squared minus 15x. Notice how in each term we have an x. Let's go ahead and put the x aside. That x is going to be our GCF, our greatest common factor. So x times x squared is x to the third, x times 2x is 2x squared, and x times negative 15 is negative 15x. Now let's identify a, b, and c. A is 1, b is 2, and c is negative 15. Let's use the x method. We'll write a and c at the top and put b at the bottom. 1 times negative 15 is negative 15, and 2 is going to go at the bottom. Now we need to think of two numbers that will multiply to negative 15, but will add up to 2. And those two numbers are 5 times negative 3. So 5 times negative 3 is negative 15, and 5 plus negative 3 is 2. Now take those numbers and divide by a. A is 1. Put the x's at the bottom. And from there, write the factors from the bottom up. So we have x plus 5 times x minus 3. And remember, no one gets left behind, so let's go ahead and bring down our GCF, which is x. So the final answer is x times x plus 5 times x minus 3. Let's look at another problem. In this problem, we have a binomial. When you're asked to factor a binomial, try to look for the greatest common factor. The greatest common factor in this problem is 2 times y to the third. 2 goes into both 2 and 18. And y to the third is the smallest variable. 2y to the third times y squared is y to the fifth. And 2y to the third times negative 9 is negative 18y to the third. Now if you look at the binomial, notice how we have a difference of two squares. Difference of squares are special because they take on this pattern. So a squared minus b squared, and once again, this is a difference of squares. When you factor this out, you'll get a plus b times a minus b. With that pattern in mind, let's apply it to y squared minus 9. So I know y times y is y squared, and 3 times negative 3 will give me that negative 9. And once again, I used the difference of squares pattern. Let's also bring down our GCF from earlier, which is 2y to the third. So our final answer is 2y to the third times y plus 3 times y minus 3. Moving on. Factor the polynomial completely. We have 4z to the fourth minus 16z to the third plus 16z squared. This is a trinomial, so I'm going to try to use the x method. But first off, let's check to see if there's a GCF. 4z to the fourth minus 16z to the third plus 16z squared are all divisible by 4z squared. 4 goes into 4, negative 16, and 16. And z squared is the smallest variable. 4z squared times z squared is 4z to the fourth. And 4z squared times negative 4z is negative 16z to the third. And 4z squared times positive 4 is 16z squared. Now that we have our trinomial, let's identify a, b, and c. A is 1, b is -4, and c is 4. Use the x method. Let's write a and c at the top and put b at the bottom. So 1 times 4 is 4, and -4 is going to go at the bottom. Now we need to think of two numbers that will multiply to 4, but will add up to -4. And those two numbers are -2 times -2. -2 times -2 is +4, and -2 plus -2 is -4. Now take those numbers and divide by a. A is 1. Try to reduce the fractions if possible, but if it's not possible, then go ahead and write your factors from the bottom up. These are already in their simplest form, so we're ready to write out our factors from the bottom up. We have z minus 2 times z minus 2. Let's bring down the GCF. So we have 4z squared times z minus 2 times z minus 2. And because we have two of the same kind, let's go ahead and condense this so that we end up with 4z squared times z minus 2 squared. So when you factor 4z to the 4th minus 16z to the 3rd plus 16z squared, you get 4z squared times z minus 2 squared. This concludes our lesson. If you like this video, go ahead and give it a thumbs up and don't forget to subscribe.